just a couple more things in section 5.1. The next is another theorem. It's called the triangle inequality. This is another thing that is used very often to prove other theorems in mathematics, but again, not super practical in your everyday calculations that you're going to be doing in here. And the reason why is it gives you an option of how big something could be. It gives you a limit on that, but it does not actually tell you the final answer. So all this says is that if you add two vectors, you take the length of it, it's going to be less than or equal to the length of the individual vectors added. And the picture for this is if you have a vector x and you have a vector y, and you go ahead and add them to get the vector x plus y, then you form a triangle. And you should know that on any triangle, one side is never bigger than the other two sides put together. Or another way of saying that is if you want to get from point A to point B, the fastest way is always going to be to go straight here, not going to some other point C in between them. Right? So that's what all we're saying here is the shortest distance between 2 points is a straight line. FYI, there is some geometries out there where the shortest distance is not a straight line, but they're not the focus of our class, so I'm just mentioning that briefly. And the last thing that I want to mention in 5.1 is the Pythagorean theorem, which is actually something we will use on solving problems. And what it shows is if x and y are, and the word is orthogonal, you could just say perpendicular. Mathematically, they mean the same thing. And that means that the angle is 90 degrees. Then the following is true, that the absolute value of x plus y squared is equal to the absolute value of x squared plus the absolute value of y squared. So looking at this picture up here, it's just saying if this was a right triangle, you would have the Pythagorean theorem. And the nice thing is this works not just in R2 or R3, but it works in any Rn here. And so if you happen to know vectors are perpendicular, you can take advantage of this and use that to find different sides. And so that's the end of section 5.1. What we're going to be doing next week is moving on to trying to do the same concept of dot product and length and angles, but trying to do it in weird vector spaces. For example, what does the dot product of two matrices look like? Right? We'd like to see what does that mean, or even better, what if I have the polynomial x squared minus 3x plus 2, and I want to dot product that with 5x plus 7? Again, we need to figure out what does that mean. So that'll be the topic for next week.